Let's consider this neural network with 2 input neurons, a hidden layer with 3 neurons, and a final layer with 2 outputs. As before, the weights and biases are randomized. We start off in the 2D plane with a uniformly distributed square of points. But now instead of mapping from 2 to 2, we're mapping from 2 to 3. To do this, we need to rotate into the 3-dimensional space. From here, we can perform a linear transformation of the weight matrix times the input and add the bias. Now we need to talk about ReLU. If you recall, it only preserves positive inputs, and in 2D this was the first quadrant, so in 3D this is going to be the first octant. Thus we fold every other input into the plane of the axes, revealing this triangle-like shape with folds in the first octant. And now we do another linear transformation back to 2D and add the bias term. Notice how this blob is completely different from anything you could get with a linear transformation. This once again shows us the importance of the activation function